Welcome to Lecture 5 in Populations and Urbanization. So as we start off our adventure in learning about urbanization and population, I'd like to talk to you about learning objectives. Oh, by the way, see if you can find old Waldo over there while I'm talking about your learning objectives. Kind of hard in that bunch of people, isn't it? We're going to look at the terms associated with population growth and urban development, some very specific terms, and we'll evaluate problems with the population levels. We'll be discussing human demographics and looking at birth rates and certainly trends. And then we'll assess the big question, which is what to do with the problems of overpopulation and overconsumption. Did you find Waldo yet? He said he's in there somewhere, so you might want to keep looking. Kind of an interesting little video, isn't it? And as you start to look at the most typical male in the world or person in the world, you look at that 7 billion people in population, which I might add is growing, and you take them standing shoulder to shoulder, all we would need is 500 square miles, about the size of Los Angeles, to squunch all those people together. That means shoulder to shoulder, no breathing room, everybody smushed into the same place. If the entire population were settled as densely as New York City, we could all fit into Texas. According to National Geographic, the most average person in the world is a 28-year-old Han Chinese male who speaks Mandarin and practices Christianity. Another important fact that's out there for population is 2.8 billion people live in extreme poverty. So in that video you watched, it pointed out that people have different choices, and that choices dictates kind of how they spend their day. And that's something to think about, because our choices, the more choices you typically have, then usually the probably higher income that you're making. So the people who are living in those poverty states, their choices is all about life and death. It's how to meet survival. So let's look at some terms applied to population. Couple of key terms, of course, you could imagine the definition of population would be there. This is a group of individuals of the same species living in the same geographic area at the same time. You've had this definition already. So what's population ecology? The study of these populations and why their numbers change over time. Why do the numbers we see on the left here of your screen vary according to decades, century, millennium? How does that work and why are the population trends the way that they are? So demography is a study of applied branch of sociology that deals with population statistics and provides information on the populations of various countries and groups of people. So one of the things in the video that pointed out that the population will change and the average person that we see that's a Han Chinese will be coming out of India, so that population shift will occur. So demographics is the application of population statistics. So when we look at those statistics and we kind of evaluate and draw conclusions on what's happening based on the interpretation of that data, that's important in any line of work. So you're looking at the demographics of, for example, a community college, you would want to know who your typical student person is. Who are you wanting to serve? What are their needs? And you would want to meet those. So in terms of looking at it from a holistic point of view, if we look at population as a whole for the world, we're trying to do some prediction factors as well about how are we going to meet our resources and demands for resources such as water, wastewater treatment, waste disposal like trash. A couple of other important terms is population density. These are the number of individuals or species per unit area or volume at any given time. And when we think of urbanization, population density becomes important in the understanding of where the limit can be to put all those people, which brings me to the next term, which is environmental limits. These are problems within an ecosystem that commonly involve food, water sources, which can limit the growth of a local population. So if you grow too quickly or you have too much demands on that environmental limiting factor, you could imagine that the population could plummet. So you kind of reach what's called an ecological threshold, which is a limit by which the ecosystem can be sustained. And when you supersede that in the environment, whether it's humans, it's cockroaches, it's those bunnies, doesn't really matter. Whatever it might be, if you exceed that number, usually there'll be a dramatic decline rapidly in terms of a crash for that population, if not an extinction. Carrying capacity. This is the maximum number of individuals that an environment can support, notated with the letter K in the equation we'll be looking at shortly. So if you have a carrying capacity that's lower than the environmental resources, you can imagine it could be sustained. If it's equal or above, there can be some issues. So what's that population crash I was talking about just a few minutes ago? An abrupt decline in population density. This has occurred all throughout geologic time, and really, if you want to be honest about all the 100% of living organisms that we have identified in the geologic rock record, literally about 95% of them have gone extinct over geologic time. So the success rate has not been that high for longevity. That does not take into account that they've evolved over time, and we mentioned that in one of our last lectures. So let's look at growth rate. This is the amount of species born per thousand per year, notated by the letter R in the equation that we'll be using to determine population growth. So R was that population growth, B is births minus D, which is deaths, plus in parentheses I for immigrants minus E for immigrants. So what's the difference between an I and an E? I is coming in, immigrants are leaving. So you divide that by 1,000 and then you determine your population growth. All right, more terms. Survivorship, the probability A given individual in a population will survive to a particular age. So you noted in the video that a woman from Japan lived almost twice as long as one from Afghanistan. And so there could be environmental factors, there could be food factors, all of those things could dictate why that could be. A few more terms to learn about population. Survivorship is the probability a given individual in a population will survive to a particular age. So you noticed in the video that a woman from Japan lived into her 80s while one in Afghanistan lived to her mid 40s. What is the reason for that? You could evaluate a number of thoughts that could come to your mind, but there's some environmental factors and other factors that could play into that. Two things to consider why those two age differences could be so different would be to look at density dependence and density independence. So let's take the example of rain and define each of these terms. Let's define density dependence first. It's a factor whose effect on population changes as population density changes. So if you have a herd of cows and they're considered livestock on your property, rainfall is required for livestock to have water to drink. So let's assume that you have a stock tank, right? So you need that water for them to drink. You could use a windmill to try to extract it from groundwater, or you could produce some way to get water into that tank if it wasn't raining. But raining is the key way that water recharges groundwater systems and certainly adds in water concentrations or volumes into something like a lake or a pond. So how's that different from density independence? This is a factor that impacts population but is not influenced by changes in the population density itself. Let's use that same analogy of rain. It will either rain and fill up the stock tank you have on your property, or it won't, right? And the tank will end up drying up. If you don't have cows, how is that related to their density and their dependence on that water? So you have to kind of look at, for example, I'll use the African Saharan desert. It may not rain there much, but what's the dependence on the rainfall amount of what does live there? So what's living there is very adapted to those conditions. And so when you're looking at a population of something, you have to look closely at the density dependence and the density independence factors. In population and survivorship specifically, we look at three different types of survivorships to define how a population extends or is able to sustain and extend itself. Type 1, the young and those at reproductive age that have a high probability of living. For example, humans and elephants. So how is that type 1 different from a type 2? This is the probability of survivorship that does not change with age. A lizard, a mouse, a squirrel. Their survivorship isn't going to change whether they're little bitty or they're elderly. Now you could argue, well, what if they're sick or they're brand new babies? Okay, I can get that point. But as a general rule of thumb throughout their life cycle, it's not that big a deal. So when you're looking at type 3, this is the probability of death is greatest at a young age. Krill, which is the base of the food chain, it looks like little bitty shrimp, fish, and sea turtles have a very high risk of death shortly after birth. And if you know much about sea turtles, they have to run to the ocean, and many of them don't even make it to the ocean. Once they get there to the ocean, there's predators, there's the potential for drowning, there's all kinds of factors that could limit their success to grow to adulthood and reproduce. So current trends in population growth and development are rather unique, so let's take a look. You may be wondering what the BCE stands for, before current era. I have a little bit of issue with that term. It's a population term because geologically speaking, eras are made up of millions of years, literally hundreds of millions of years, if not billions of years. But nevertheless, population people didn't ask me. We'll use it for what it is, before common era. Good test question, you should know that. When you look at 10,000 years before common era, it was 1 million. So you can see that there's been a change over time. As you get to closer to the current time, our numbers have exponentially grown. In many cases, more than exponentially doubled, certainly from the 10,000 to 4,000 year marker. So you have to ask yourself why. And we all have hypotheses on this, but proving it's a little bit more tricky. So at 4,000, we have 7 million people. At 3,500, we have 10 million. Look at just 500 years later, we have 14 million. And 2,500 years ago, 20 million. What's going on to cause that to occur? So if we look at the year of current era, so that's what CE stands for, 1 year of current era, we had around 200 million people. At 1800, we had 1 billion. Wow, so 1800 years later, we went from 200 million all the way up to 5 times that to make 1 billion. By 1930, we had 2 billion. Are you seeing how quickly this process is going? So in 130 years, we doubled our population from 1800 to 1930. From 1930 to 1960, note that that's only a 30-year marker, we grew by another billion. This is a really important time in the world's history, and certainly in the United States history. When you look at 14 years later, we doubled again. So half of the time that we had from 1930 to 1960 to jump a billion, we did it in 14 years instead of 30. And by 1987, it was 5 billion. So you should be going, wow, it's not taking long to get there. By 1999, we reached the 6 billion mark, and I can remember at the change of the millennium in the 1999 celebration to 2000, people were screaming and hollering, oh, the world's going to come to an end because we've reached 6 billion people and our carrying capacity is beyond what it can sustain. Unfortunate for us, that trend has continued. So let's look at 2011. It's 7 billion. So it took us only 11 or 12 years to do that, not very long. It's projected, by the way, you need to know when we hit a 2011 marker. So make sure you know what the population was, estimate of 7 billion. That's an important date to know because that's such an element of change for the world to have hit that 7 billion mark so quickly. It's estimated by 2024 that we'll be up to 8 billion. And when we get to 2045 or sooner, depending on the birth rates of humans and the longevity of humans, we could reach 9 billion. So you think about that and you start to ponder, how are we going to meet the needs of all of those people? And then you start getting to ethical questions. Should we be meeting the demands of all those people? So that's a hard issue to debate, and I'm not sure there's a right answer. I mean, you could look at it from surely a speculative sociology point of view. You could look at it only from a scientific point of view. You could look at it from a political, economic view and come up with a different answer or a combination of answers in any of those circumstances. So population growth rates, let's take a look at how the growth rate percentages have changed over those same time frames. In 1960, there was a 22% growth rate. That counts for kind of like those 14 years of doubling in population rate. You got to think about what was going on during that time, especially by the late 1960s, early 70s. So in the 70s, by 1970, we had a 20% growth rate. We dropped a little bit, but we're still cranking out humans pretty quick. 1980, it dropped slightly to 18.5%. So what's going on there? 1990, we had 15.2%, yet our population continues to grow. By 2000, remember that 1999 thing where we hit the 6 billion people, we dropped down to 12.6. Now you're like, something's not adding up here. So you got to be thinking about either spectrum of the population. You've got the newborns, and then you got the people who cannot produce anymore or will not produce anymore, meaning reproduce offspring. And so you get fewer people in the middle that have that capacity doing that. By 2010, we dropped down to half of what we were in 1960 and 1970. It's 10.7%. By the year 2020, it's projected that the population growth will be at 6.8% every 10 years. So the growth rate has slowed since the baby boom, bottom line. So why is the population growing at such a fast rate? That's the $7 billion question, meaning the 7 billion people question. Let's take a look at it. Has to do with the fertility rates. As we start to make estimates throughout time, you can see that as this GIF is running, you can look at the fertility rates and notice that the population is changing in terms of the median projection over time. And so as this episode occurs, notice that there's one continent in particular that doesn't see as much change as the rest of the world, but it does by the time we reach another century. So as you're watching this go by, you can see that Africa is slower to catch up with the rest of the world. So how does that apply? Does that have to do with poverty? Does that have to do with demographics in terms of looking at where they are in latitude on the planet? Maybe all of those factors affect that. But I kind of want you to look at how North America is changing very quickly. Russia's changing, Australia, and then you see that some of the large countries and third world countries are taking a little longer to catch up, except for parts of Asia. It's interesting thoughts to contemplate. What are the generational names and why is that important to us? So let's first talk about the silent and the greatest generation. So my grandmother was born in 1898. And she lived to be about 90 or 91. I think she died at 91. Nevertheless, she would have been precursor to this. So let me put my mom and dad in this equation. They were born in 1928 and 1930, respectively. So if you take a look at that, they would be in the silent greatest generation. What does that mean? So during this time, we had already had World War I thing happen, and the Great Depression occurred. So you definitely can correlate that to this generation basically did what they were told, they used what they had, and they were some of the people that were the most resourceful of the legacy over the last century or more. Then we had the baby boomer generation. So I think I've mentioned earlier in the semester that I'm adopted. So the parents I just referenced were my adopted parents. So let me talk about my biological mom for a minute. I never got to know my biological dad. He died before I could reunite with them. But both of them were baby boomer generations. They were born either from 1944 to 1964. So she was born somewhere in that time frame. And you can kind of look at what was going on during that. So we have World War II that occurred. And you can read between the lines and see if you can apply a mechanism as to why we would have had an increase in population during that time. Then we move into the Generation X people. That's where I fall. So I'll be happy to tell you I was born in 1968, so I definitely fall under Generation X. I'm actually almost a baby boomer, but really I'm a Generation X person. 1965 to 1981. And Generation X people, when we were young, people that, let's say, pre-1980s, there wasn't an internet. Internet really didn't evolve until I was in college. And so I can remember the first email address that was like a big deal, like what's email? How do you do it? And it was kind of a really fascinating thing to get on the internet. I remember thinking the internet was this thing, and I never could really grasp my head around, in my mind around, that it was really fiber optic cables carrying information that's invisible, right? Just in the form of data points. And so today, when you look at the generation that came after me, Generation Y/millennials. So what are they? They were born from 1975 to 1995. My biological sister would fall into this because she was born in 1976. And she is a millennial to the T. I mean, millennials have their very specific way they do things, and their mindset's much different than Generation X, baby boomers, and certainly the silent greatest generation. Their access to technology is much higher. Their proficiency with technology is much higher. They can pack more into a day and get it done, generally speaking, than some of the other generations. Not speaking for or against them, I'm just pointing out some of the obvious things that have happened that have enabled that process to occur. So I know in the silent greatest generation, if you get like my mom, who's just turned 86, to try to turn on a computer and send an email, it's literally like trying to teach them how to build a car or learn a foreign language. She'd be more inclined to do that than she would be to learn how to send an email, because that technology is not familiar to them. You would more likely see a baby boomer that would have figured out they needed to have learned that and learn those skills to survive in the latter parts of their careers. Then you get into Generation Z. There are other names for it, but Generation Z exists from 1992 to current. So what are we going to call the new group? I don't know, to be frank. But it'll be interesting to see what that new generation looks like, because there's one that is actually evolving past to Generation Z. And it will be fun to see what they look like. So when we look at demographic transition, let's talk about what that is. It says living conditions improve. A country enters successive phases of a process where the death rates decline or fall, but there is a lag between or before the birth rates decline also, resulting in a temporary population soars. So basically, before that process can happen where the birth rates slow down, you'll see a spike in population, much like the United States did back in the 60s and 70s. Annual global growth is about 80 million people. That's just a lot of people to think about. Each new demographic phase is marked by redistribution of the population's age group in terms of what's the median age, and it's kind of what the video was showing you. So what do we expect that to look like in 2099? Is this what we're going to see on the left, or is it going to look like something completely different? I don't know. I doubt I'll get to see it, but you might. Future population growth. The U.S. population density in 2045 will likely be comparable to present-day France, and the global middle class will likely rise from about 400 million in 2005 to slightly over 1 billion people in 2030. That's going to really change how the economy works, just projecting that. I'm not an economy person, but I know enough about it to know that that's going to change supply and demand. Most growth will occur in underdeveloped countries. Fertility rates in Europe is 1.4%, putting it below replacement rate. So what does that mean? If you have a birth rate and you have a fertility rate that's less than the replacement rate, eventually your population will start to decline, if not completely eliminate itself. And let's be frank, this is what's happened in geologic past to a number of organisms. Don't think that catastrophes killed all the organisms in geologic past, some major mass extinction event. There's only 6 of them recognized, of which 1 is currently in progress. So 5 ancient ones. So we don't have that specific thing happening at this moment in terms of the things that caused, for example, the Great Dying at the end of the Permian period. If not for immigrants, the United States population would likely be declining, similar to Europe. I can think back when Back to the Future came out, which is the picture you see here, and it's a fun series of shows if you've not seen them, and Michael J. Fox, and going back in time and then trying to get back to his current time and getting a glimpse of what like his parents would have lived like. It was a kind of a lesson in the change of population over time. So the impacts of large populations, what are the pros and the cons? Let's start with the good news, and then we'll work into the not so good news. The pros: large populations create more jobs. That's a good thing, right? Because more people means more opportunity, and the need for those services increase. Large populations also provide the potential means for a strong work pool, assuming that those people can work, right? So I can see your brain going off. You're thinking, what about this? What about that? Good for you, because that can all be changed based on what the population is made out of. Same thing in statistics when you're looking at data points. Are the data points accurate? What could influence those? You always have to acknowledge those anomalies. So what are the not so good news or the cons? If the large populations are poor, they cannot pay for any of the services provided for others. That's not good, right? Large populations require more resources and stress municipal infrastructures. What do I mean by that? Things like wastewater treatment plants, things like landfills, things like water infrastructure to get water to people's homes and businesses. These are all things that we don't necessarily think about when we think of population growth. That's not usually the first thing we think about, but it's the long-term thing that I want you to think about after taking this class. So what's the quality of life of people? Internationally, quality of life is determined by a series of the following. Environmental degradation. And that is definitely in the works around the planet. Health issues. Duh, you're like, gee, Elaine, that was like a no-brainer. Urban deterioration. I'm from Houston, Texas. There are areas of Houston, buildings are run down, hardly anybody lives there. There's a lot of graffiti, a lot of trash, known for insects, varmints, vectors, just not a clean, healthy place to be. So that's one of the reasons that downtowns typically get revitalized, and I can think of Waco, Texas is going through that right now. So since McLennan College is located in Waco, Texas, I can tell you downtown looks a lot different than it did even 5 years ago. Persistent poverty and hunger. So when you look at the best value of life, where is that? And how do we quantify that? How do we qualify that? Let's look at worldwide population trends. 29% of human population is under the age of 15. That means just about a third, not quite, but just about. So definitely over a fourth. About 35% of the human population is under the age of 18. So now we've surpassed the 33% mark, the 1/3 mark. The average human is 28 years in age, and Europe averages the oldest humans. I think that's kind of interesting. Africa averages the youngest humans. And so if you look at our chart, or over here on the right, the bar chart, you can see that Africa has much younger humans, and I would tell you they also have a shorter lifespan. So you can think about the reasons why that would be. Why does Europe have the oldest humans? What causes that to occur? Even more so than North America, but we're next in line for having the second oldest population. Population characteristics can have something to do with Africa versus Europe. So let's look at that. Underdeveloped countries. In no way am I saying that all of Africa is underdeveloped. That is not true. There are some very highly developed parts of Africa, but some of the least developed parts of the world are in the continent of Africa. They marry at a younger age, and they almost have to since their lifespan is so short. They produce more children per family. Women are considered successful if they provide many children. Family sizes are also rooted in the culture of how they believe in their infrastructure because children work. And that certainly used to be the case in North America when people started colonizing our continent, was children were favorable because they helped with the work labor. Underdeveloped countries represent 95% of the future population growth, and that is a sombering thing to consider because there's not much we can do to help that situation. Every year you see rallies to try to raise money to deal with this issue in terms of hunger, but you need to look at that percentage. 95% of future population growth represents underdeveloped country. And U.S. in 1800 was an underdeveloped country. So when we were settling our grounds here and people were beginning to colonize and starting to move west, that certainly was the case for us. So let's look at the developed country list. They marry at an older age. They have smaller families. Women are usually considered successful not based on birth rates, but considered based on their checkbook or their amount of wealth they accumulate. Population levels are likely to decline by 2050 in a developed country, and developed countries experience a replacement fertility rate of 2.1%. That's the United States in 2000. So you might have thought we were developed before then. Many people would have assumed that we were, but using a reference number that you can relate to, most of the average population in this course right now, we were certainly developed by the year 2000. Population characteristics. Women with the higher educations typically have fewer children. I guess I'm one of those examples. I have 0 children by birth. I certainly have 2 stepchildren, wonderful kiddos who are adults now. But I have spent most of my life in education, not necessarily in the field of education, but gaining education in one sense or another, which has not left me much time to have children. Women in the United States average 2 children. So even my adopted mother and father made a decision to have 2 children when they adopted. Even my biological parents opted to have 2 children max. Why is this the case? Women in India have an average of 2.6 children, so there's a little bit higher rate there. So when you start to look at the rates of education on the left here, your bar chart, you can see where the birth rate gradually goes down, well, actually significantly goes down from having no high school graduation efforts, maybe even no education, formal education at all, except for in trade and what they learn from their mothers and fathers. Then you see a high school graduation or graduate, a bachelor's degree, and a graduate or a professional degree. So I have a bachelor's and a master's, and I'm pursuing a terminal degree now. So that would put me in this last category here. So look where you are. You're pursuing one of these, and you may have 15 children. I don't know. But if you did, I would bet you that's not dictated by where you live. That's more based out of cultural and potentially even religious beliefs. So let's look at fertility rates around the world. And I highlighted the lowest and the highest. So when you look at South Korea, they have a 1.2 fertility rate around the world. Ultimately, that means that their population could actually start to decline because they can't reproduce faster than they can with the amount of people having children. And you look at Chad in Africa, it's just the opposite on the opposite side of the extreme. And you can see some of these other countries around the world, but I just wanted to point out a handful of these. 6.2. So when you start to look at the list, you begin to go, interesting stuff here. I wonder what's going on. And you can start picking out countries. So Canada 1.6, US 1.9, Mexico 2.2. I've been to Australia 1.9, New Zealand's 1.9. You come over to Congo, and that's in an underdeveloped section of Africa, 6.0. And then you come over and you look at Japan at 1.4, and you look at Israel at 3.1, you begin to paint a picture, Saudi Arabia at 2.8, and you begin to think about why those things could be. Well, let's just kind of cut to the chase, get over the elephant in the room and talk about it. Contraceptives and development. That has something to do with it. Contraceptives are often used almost exclusively, actually, and developed in developing countries more than underdeveloped countries. Remains a very controversial issue, and in no way am I saying it's right or wrong. That's not what I'm here to say. I'm simply reporting the statistics and the information to you. So why is it so controversial today? Because of ethical reasons associated commonly with religion and morality. Is there, the basic argument is, should we be intervening with the overall plan? If there is a supreme being, with that supreme being, or with our own ethics, should we let nature take its course? In some places in India, the government will pay a week's wage, which is about $25, to receive a vasectomy, because they have so many people in such a crowded space that they're actually trying to reduce their fertility rate. In some places in underdeveloped countries, sterilization, quote-unquote, camps have sprung up in rural areas to provide free and cheap vasectomy and tubal tying off to try to help with this problem. Eventually, you run out of resources, and that's a really bad thing to witness, because when people run out of resources, horrible things happen to them. Same thing in the animal world. And I'm going to talk about Ethiopia for a second, because back when I was much younger, there was a real big push when Ethiopia ran out of water and food. And that's a whole nother story for another day. But they were starving, and some of the similar characteristics still exist today. But there was a real movement, especially from the music industry, to try to help these people and feed the world, to help the world with hunger. And hunger is a real thing. And eventually, if you run out of space or if you run out of the environmental resources, the impact and slow demise of a lifetime for these people is it's almost impossible to watch. Morally, I can't. And so I look at that and I think, what have I done? What can I do to help with that situation? That's the moral side. The scientific side of me also says, well, wait, let's think about this. And then the sociology side of me takes hold, and the economic side. And so there's a struggle even within each and every one of us to probably contemplate this topic. It's a tough topic to address. The China one-child policy, this becomes a question asked in every class about population. In China, citizens were only allowed, and I'm talking legally allowed, to have one child between the years of 1978 and 2015. That's not too long ago. So the penalty for having an additional child was 200,000 yuan or yen, which is about $31,000 and 250. So in other words, right around 31,000-ish dollars. It was a lot. If you want to think about having a child and it costs $31,000, that's almost like an adoption, depending on where you adopt. It estimated to have prevented between 250 to 450, hit this word, million births. Wow, my brain can't get around that. In China, the current fertility rate is much lower than it used to be, but that number was not the case back when they started this in 1978. The penalty for single mothers is still in place. The fine for excess children is called social maintenance fee. I'd hate to see that on my tax report. You're getting a social maintenance fee, but that's my personal opinion. Maybe it's a good thing, I don't know. I'm not the one to say I'm right or I'm wrong. You may have a very strong opinion on this, but I will tell you that this policy that they put into place, this legal mandate they put into place, really reduced us jumping to the next billion faster than we should have. And that's one reason that we have not surpassed 8 billion in population. The Brazilian population shift, this is an interesting correlation. In Brazil, the population has declined rapidly following the development of electricity. I wonder why that is. There's some hypotheses and actual scientific data to support that the developing countries that have access to television and internet have reduced birth rates. Those countries that do not tend to have higher birth rates because people can occupy their time doing the things that make children. With electricity came television and evening programming taking up people's time. Call it like it is, right? It is believed by many demographers that the population of Brazil began to decline when people saw small families on television, had less time for other things, and because there was a rise in female education. And we correlated that earlier, showing that the higher level of education for a woman, the more likely they were to have less children. Today, the fertility rate is 1.8 as compared to 4.3 in 1980. So in less than 35 years, they have literally cut their fertility rate in half, more than half. When you look at the demographics and economics, this is a tough one. Human demographics often detail the type of country being studied, and the higher age averages typically demonstrate the level of industrial development. That's certainly the case for the United States. So if you look over here at the blue line, you can see the blue line kind of levels out with time over here, and you're looking at post-industrial here's industrial, transitional stage, pre-industrial. So you're looking in the 1700s, the 1800s, well really 1750 is when the industrial period quote unquote started. But then you see where we are now. So this is kind of where we are now. And so you see the birth and death rates over here, number per thousand in population. As the birth rate declines, the death rate stayed pretty constant here, but the longevity of life has certainly increased. So that's important to recognize that that population, you're getting an extreme, especially over here on the bell curve, how long people are living. So what's the pre-industrial stage, and understanding that, comparing this to economics? Birth and death rates were high. They had a modest population growth. Transitional stage, they lowered their death rates, but they had rapid population growth because they had access to more technology, more resources, they were making more stuff. During the industrial stage, birth rates declined and population growth became more slow. During post-industrial stage, where we are now, there were low birth and death rates, and population growth was very slow. When I'm saying us, I'm referring to the United States, and you can include Canada in that, so North America per se. So what are population pyramids? We kind of look at what's happened with male and female growth in numbers and populations, their ages, and the percent of the population that they make. So let's start with the United States and work on either side of that. So you see that our male population and female population, remember we looked at the 60s and the 70s, let's come up here and you can see, whoo-wee, yeah, these fat areas. So this was starting, right in the World War II, and this is all the way through the Vietnam incident, this section right in here. So we have a really big growth period, and then it starts to slim out. But overall, you can see that at one point we had, way back here, more females than we did males. And what could that be attributed to? Could that be attributed to a wartime issue? Maybe so. Now, let's compare that to Germany. Look at their population, and then you can see that we kind of have a higher percent of population than they do. Well, their fertility rates have gone down. Well, let's come over here to Kenya, and you got to think about where Kenya's location is geographically. So they have a much broader early age population, and then as you start to get into the later ages, they definitely have a pinpoint, unlike we see here. So let's look at the average age of someone that's 75 to 79 or 80 plus. Females outlive males in the United States. I would agree with that. My mom's lived longer than my dad, and most of the widows I know, their husbands died many years before they died. And you look over here in Germany, it's even almost not quite double, but what we see in the United States. So women are living longer, and it is definitely an issue for our higher, or I don't even want to use that word higher, but our more industrial higher level of influence to the culture, where here that's not a factor. And so the male and female ratio, even though females tend to outlive the males, it's by a slim margin. Population trends. Over half the world's population lives in urban environments. Urban areas are often determined by a type of job, not necessarily population density, although density does play a role in that. Characteristics of an average global urbanite. I grew up in Houston, Texas, although I was suburbia. I was not in the actual downtown area. Female, young, single, above average education for the region, entry-level, low, middle-class vocation, and commercially based, not industrial. That's kind of an interesting set of facts, isn't it? So population and economic growth, when you start to look at the GDP, which is the gross domestic product, went from 29.8 trillion in 1980 to 72.5 trillion in 2009. Wow, what's going on with that? So let's take a look at each of these countries. China's gross domestic product grew 1,506%. I think that's important to know for a test during that stretch of time. Japan's grew to 74%. Africa's really is impressive for considering what's in Africa in terms of industry and where that comes from, 151%. Europe's was 75%, and the United States grew by 119%. So we look at that gross domestic product during the 1980s all the way to 2009. So why aren't we looking like China's? Most of our industrial growth happened decades before 1980. The dust dome is a dome of heated air that surrounds an urban area and contains substantial air pollution. That could extend from any kind of criteria air pollutant to hazardous air pollutant as defined by the Environmental Protection Agency. So things like volatile organic compounds, particulate matter, things like lead, carbon monoxide. I will tell you that air pollution regulatory-wise does not include carbon dioxide, although that is a factor. Methane gas would be another. So you start to look at those items, and then hazardous air pollutants is a whole nother category. I do want you to realize that smog is a very common phenomena in an urbanized area because you typically have all these people migrating usually to the urbanized sections of a city, which is usually downtown, in mass quantities, which is one of the reasons for the rideshare programs in big cities. And they're usually traveling at certain points of the day. Depending on their latitude, meaning are they, let's just say Houston, which is around 31 or 30ish degrees north latitude, that's still warm enough, especially during the heat of the summer, where you can start to have chemical reactions occur during the summer, creating smog. Compact development, the designs of cities in which tall multiple unit residential buildings are close to shopping areas and to job locations, and all are connected by public transportation. So I think in Houston, one thing they lack is a rail system or a subway system. But you think about New York City, the subway is the heart of the city. I mean, it's what links the different parts of the city together. What's a megacity? This is a city with more than 10 million inhabitants, and it's based on a formula for a square mile, actually. Urbanization requires extensive land planning or land use planning. Without it, it will not work and the city will not sustain itself. So this is the process of deciding the best uses for undeveloped land in a given area. It assists in preventing fractured development, and urban land is required via zoning, and that's actually something that's done in the county clerk's office. Basically, it's determined a city votes to say, we'll make this area an industry zone, we'll make this a residential zone, we'll make this a commercial zone. And then they put it into these three areas, which I just meant commercial, residential, and industrial. So you can't decide to build a house in the middle of an industry area that's been zoned, nor can a commercial area decide to build right in the middle of your neighborhood. It's all zoned, and that's pre-done. So you have to get those things approved before you build to make sure you're in the right zone. Urban agglomeration is the urbanized core region that consists of several adjacent cities and their surrounding developed suburbia area. I would say Houston, Texas is definitely a factor of this. Sometimes these areas are referred to as tunnel towns. So you think of Houston, there's Humble, there's Clear Lake, there's Friendswood, then there's Katy, and you start to look at all the different sides of town, and it becomes one big Houston, Texas. What are brownfields, which you're looking at the right? These are properties that may have been contaminated from pollution. And the idea is that these are areas that usually are underserved sections of town because you have declining infrastructure that leads to more crime, that leads to more pollution and illegal dumping, fracturing of residential neighborhoods. So the idea is to revitalize brownfields and turn them into something useful. Another thing that's a trend in urbanization nowadays is to produce sustainable cities. That's a city with a livable environment, a strong economy, and a social and cultural sense of community. Sustainable cities enhance the well-being of current and future generations of urban dwellers, which is the idea and premise behind revitalizing downtown Waco, for example. Suburban sprawl, what is that? It's a patchwork of vacant and developed tracts around edges of cities containing a low population density. So for those of you who live in Waco, I can tell you that China Spring used to be a suburban sprawl. Now it's becoming very densely populated, and before long it'll just be one stretch of Waco. And I can remember in Austin, Texas, back when Round Rock almost took 30 minutes to get to from Georgetown when you were traveling on I-35, and certainly another 30 minutes to the Capitol in downtown Austin. Not the case anymore. It's one contiguous, solid suburbia infrastructure, but that used to be suburban sprawl. What is urban heat island? This is an important environmental factor and people don't often think about it. But the color of surfaces of the earth are important for determining and aiding in climate. And we'll be looking at that in our last two lectures for the semester in this course. So an urban heat island forms around a downtown area where artificial surfaces trap excess heat during the day and also creates dust domes from pollution. Can actually contribute to the formation of smog. It can lead to hotter temperatures by nature simply because of the asphalt and the color of the asphalt and or concrete. Long commutes create a large presence of airborne emissions that I mentioned earlier, like criteria air pollutants, and overdependence on natural resources to build infrastructures can put a demand on water, sewer, and landfills. And populations grow more from immigration than from births in an urban heat island environment. So looking at this temperature chart, you can see that there's areas that have really high temperatures as compared to some of the more rural sections of the same area right here. And that's because of the urbanization that has happened there. And usually you're looking at asphalt, which is dark, and that absorbs the heat, doesn't reflect it. Making cities more sustainable helps with that process. An example might be putting growing gardens along the buildings or on rooftops like you see here. This is becoming actually a fairly, I won't call it faddish, I think it's a long-term investment, and this actually helps with the cooling and heating of a building. One recent study published in National Geographic determined that dense cities tend to emit less CO2, carbon dioxide, per capita than the national average. Interesting. Isn't that interesting? This study determined that the most crucial factors were the city's source of energy, like is it coal, is it wind energy, is it water energy, what is it? And the effectiveness of the city's public transportation system. So if you have an efficient public transportation system, then you're likely to have less motor vehicles, which we call mobile sources, adding to the overall heat capacity and air emissions problems that we have in the city. Urban growth. As the human population grows, so does the need for additional agricultural lands, houses, transportation, and other basic resources. However, as we grow, if you look at our population today, the densest populations are on our coastal areas, and especially on the East Coast, and you work inwards towards the middle of the continent in the Midwest, which is agriculture. So eventually, if we start to need all that land for population, we're going to have nowhere to grow the food. And that's a scary thing to consider. In places like Texas, for example, viable croplands are being recovered and used and replaced by houses, businesses, and roadways. What will that mean to our long-term sustainability in terms of resources? At present in the United States, about 1 acre or 0.4 hectares of land per capita is covered with some form of urbanization and or highways. That means impervious cover. So we're looking at something like concrete or asphalt. In 1960, the U.S. had about half an acre per capita, roughly half of what it is today. So we've done a lot of building, bottom line. And with that population growth that continues, we are going to need more resources, more roads, expansion of those things, more buildings in order to make that population be able to get where it needs to go. Think about 18-wheelers. Think about the fact that they need to have a transit way in order to move our products from other countries, for example, Mexico, or from one side of our country to the other. They're constantly on the highways moving our stuff. So before you get so frustrated with one on the highway, remember they're moving our food, they're moving our resources. They're a big part of the infrastructure of keeping us sustained in terms of resources. Why does all of this matter? Why am I bringing it to your attention? Unchecked population and unchecked consumption rates lead straight to famine, and famine leads to a population threshold that gets exceeded. The next half century is going to cause radical alterations in determining what is acceptable for creating energy and securing resources. There's no two ways about it. Something's going to have to happen. Global economies will become more prevalent than even now. Asia will become an economic giant. Europe will be more of an afterthought, and the United States will remain somewhere in between. So look for Asia to start to really gain power in their economic growth, and it goes back to the percentage that they had of gross demand, right, or their product production. So how does this relate to environmental science? That brings us to our science survey. So yay, we're to science surveys. It is estimated that a child born in today in the United States will live to 120. Good grief, if I lived to 120, put me out of my misery somehow. I don't think I can, I'm just saying. I mean, I can only imagine what it will be like, and that's like 5 decades, 6, 7 decades from where I am now. It is estimated that a child born today will spend 1/3 of her or his life looking at a screen, a phone, a computer. That could have implications for our future. I can imagine our vision problems will be different in 30 or 40 years based on our contact with screens, and you're doing that right now. Sorry. Today, the most sought after female models are typically Eurasian. They're 20 years ago, they were Swedish. In 10 years, the most prevalent human being in the world will likely be a 23-year-old Indian male. In 1952, the life expectancy was 38 in India, and today it's 68. So something's happened. They're having a longer life expectancy. In 1952, life expectancy was 41 in China, and look at what's happened to it today. Skyrocketed up to 75. Close to 1 billion people go hungry every day. So where are those hungry people? They're not all in underdeveloped countries. There's some really in every one of our cities. So think about that. For each surname in the United States, there are 350 people on average. In China, there are 174,696 people that share those surnames. 150,000 people are born every day. So my goodness, that's a lot of births. According to the Pew Research Center, white and Hispanic populations are the most likely to intermarry for mixed cultural marriages, and black and white females are the least likely to marry Asian men. So with there being so many people in the world, what about other species of animals? How do they play into this? 1.7 million camels are out there. That's a lot of camels. 293 million cows. Woo! But that's a lot of milk and milking cows and a lot of beef for beef cows. 518 million sheep. I'm just saying, I've been to Iceland and all they eat over there is sheep. So sheep and goat. Just saying that's a lot of sheep. 633 million turkeys, 1.3 billion pigs, 2.6 billion ducks. Okay, drum roll, 52 billion chickens. A lot of chickens out there, aren't there? So eventually we reach their carrying capacity. I will say most of these are not wild. These are captivity, livestock type animals. 19% of all the people in the world are Chinese. 17% of all the people in the world are from India or have an Indian descent, meaning from the country of India. 4% of all the people in the world are American. You are considered high income for the global level if you make more than $12,196 on an annual basis. You're like, wow, I didn't know that. 13% of all people in the world speak Mandarin as their first language. I don't even know one word of Mandarin, so I guess I better get busy. Think about that if you're looking for a language that you might need to know for the future for business, because Mandarin is one to consider. 5% of all people in the world either speak Spanish or English as their first primary language, and 82% of people in the world are literate. That is an amazing statistic to me. So looking at a chromosome lineup, this is interesting to look at. This is actually Brad Turner's lineup. I'm going to show you mine from 23andMe in just a second. Mine looks a little different from his because I want you to show that he's 99.9% European. This is Elaine's lineup. I'm saying my chart looks different. I can get to the same chart he has, but it's very difficult to read. But why I wanted to show you this was to show you a map. So I am literally, when you look at my statistics, 99.8. So I'm a little different from Brad. Where does that other 0.2% come from? Really strange. Sub-Saharan. So like Brad was fascinated by that I had any sub-Saharan in me at all. So somewhere way back when I have some ancestors from Africa. Pretty cool, huh? So it'd be interesting to see what your cultural makeup is. Notice that most of it comes from European, and that's no surprise since the Europeans are the ones that actually colonized North America first. So let's take a look back at the remainder of our lesson for today. 23andMe. Maybe you should. When you have a couple $100, it's like $199 with shipping, and it's really kind of interesting and fascinating. But it was really eye-opening to me because they measure lots of different characteristics of your chromosomes and your risk factors for certain diseases and tolerances and so forth. And it was pretty darn accurate about who I am. So as we conclude for the day, individuality, always remember that you are unique, just like everybody else. So these snowflakes, are they unique? Yes, but like every other snowflake. So everybody in the world has a story. Everybody else is unique. We're all similar in some ways and different in others. But as you leave this lesson, think about resources. That's what I wanted you to leave with. How are we going to manage these resources environmentally for a growing population? I'll see you at the next lecture. Bye.